Local file inclusion, or LFI, is a type of web vulnerability that allows attackers to trick a website into revealing sensitive information. Imagine a website as a house and the website's files as rooms within that house. Normally, visitors can only access certain rooms, like the living room, which is the home page, or the dining room, like a contact page. LFI is like finding a hidden key that unlocks all the doors in the house. Hackers exploit vulnerabilities in the website's code to access files and folders they shouldn't be able to see. These files might contain sensitive user data, system configurations, or even the website's source code. This vulnerability exists because of flaws in how a website processes user input. When a website doesn't properly check what files it's accessing, attackers can sneak in malicious instructions. These instructions then force the website to reveal confidential information, potentially leading to data breaches and system compromise. The consequences of LFI vulnerabilities can be severe. Attackers can gain unauthorized access to critical data, modify website content, or even take control of the entire web server. Understanding how these attacks work is the first step towards protecting our digital assets. To understand how hackers exploit LFI vulnerabilities, let's use a simple analogy. Think of a website as a restaurant with a menu. You, the user, order food by selecting items from the menu. In an LFI attack, the hacker manipulates the menu order to access items that aren't listed, like secret recipes locked away in the chef's office. They do this by injecting malicious code into the website's input fields disguised as legitimate requests. For instance, a website might use a parameter in its URL to display different pages. An attacker could modify this parameter to point to a sensitive file on the server, tricking the website into displaying its contents. The website, blindly following instructions, retrieves and displays the targeted file, believing it to be a regular web page. This allows the attacker to bypass security measures and gain access to confidential information. Understanding these mechanics is crucial for developers and security professionals. By identifying and fixing vulnerable code, they can prevent attackers from exploiting these weaknesses and protect sensitive data. LFI attacks are not just theoretical threats, they pose real-world dangers with serious consequences. One high-profile example involved a popular content management system, or CMS. This CMS suffered from an LFI vulnerability that allowed attackers to execute arbitrary code on the server. Hackers exploited this vulnerability to gain control of numerous websites using this CMS, defacing them and stealing sensitive user information. The impact was significant, affecting thousands of websites and highlighting the importance of patching vulnerabilities promptly. Another example involved a major e-commerce platform. An LFI vulnerability in their system allowed attackers to access and modify customer data, including credit card information. This breach resulted in significant financial losses and reputational damage for the company. These real-world examples demonstrate that LFI attacks can have devastating consequences for individuals and organizations alike. They underscore the need for robust security measures to mitigate these risks and protect sensitive data. By learning from these incidents, we can better understand the potential impact of LFI vulnerabilities and take steps to prevent them from happening again. Protecting systems against LFI attacks requires a multifaceted approach. It's not enough to rely on a single security measure. A combination of strategies is crucial to effectively mitigate the risks. One fundamental principle is input validation. This involves carefully checking all user input before processing it. Think of it as a bouncer at a nightclub, only allowing in guests who meet the specific criteria. Another crucial aspect is output encoding. This involves transforming data before displaying it to the user, ensuring that any malicious code is neutralized. It's like translating a message into a different language that the recipient can understand without triggering any unintended actions. Regularly updating software and systems is also essential. Security patches often address known vulnerabilities, including those related to LFI. It's like updating your phone's operating system to ensure you have the latest security enhancements. In addition to these technical measures, security awareness training for developers and website administrators is paramount. By understanding the risks and best practices, they can build more secure systems and respond effectively to potential threats. Section 5. Input validation, the first line of defense. Input validation is the first and most crucial line of defense against LFI attacks. It acts as a gatekeeper, scrutinizing all data received from users before allowing it to interact with the system. The key principle here is to never trust user input. Treat all data submitted by users as potentially malicious, even if it appears harmless. This includes information entered into forms, data uploaded through files, and even parameters passed through URLs. Effective input validation involves two key steps: whitelisting and blacklisting. Whitelisting involves defining a strict set of allowed characters or patterns for each input field. Any input that deviates from this whitelist is immediately rejected. Blacklisting, on the other hand, involves identifying and blocking known malicious characters or patterns. While useful, blacklisting is not foolproof, as attackers constantly devise new ways to bypass these filters. By implementing robust input validation mechanisms, organizations can significantly reduce the risk of LFI attacks. It's like installing a security checkpoint at the entrance of a building, ensuring that only authorized personnel with valid credentials can enter. Sanitization and parameterization ensure data is handled safely. Sanitization cleans data by removing harmful characters. It's like using disinfectant to eliminate germs. Parameterization treats data as distinct from code. It uses placeholders to prevent malicious code execution. These techniques reduce vulnerabilities and protect your application. Section 7. Principle of least privilege, limiting the blast radius. The principle of least privilege is crucial in mitigating LFI attacks. Users and processes should only access resources necessary for their tasks. For LFI, restrict web server permissions. Web servers should have read access only by default. Grant additional permissions only when necessary. This limits potential damage from LFI exploits. Imagine a bank vault with multiple security layers. Each layer grants access based on clearance level. Least privilege restricts access to sensitive resources. This minimizes damage and ensures system security. Protecting against LFI attacks is not a one-time effort. It requires continuous vigilance and proactive measures. The threat landscape is constantly evolving, with attackers finding new ways to exploit vulnerabilities. Regular security testing is paramount. This includes automated vulnerability scans, penetration testing by ethical hackers, and code reviews to identify and remediate potential weaknesses. It's like conducting regular health checkups to detect and address any potential issues before they become serious problems. Staying up to date with the latest security patches and updates is also crucial. Software vendors regularly release updates to address known vulnerabilities, including those related to LFI. Security awareness training for developers and website administrators is equally important. By understanding the latest threats, attack vectors, and mitigation techniques, they can proactively build more secure systems and respond effectively to emerging threats. Think of security as an ongoing process, not a destination. By embracing a proactive security posture, organizations can stay ahead of the curve, minimize their attack surface, and effectively mitigate the risks associated with LFI vulnerabilities. Local file inclusion. LFI vulnerabilities pose a significant threat to web applications and the sensitive data they handle. By understanding the mechanics of these attacks, the potential consequences, and the practical steps to mitigate them, organizations and individuals can take proactive measures to protect their digital assets. Remember, security is a shared responsibility. Developers, website administrators, and users all have a role to play in creating a more secure online environment. By embracing best practices, implementing robust security measures, and staying vigilant against emerging threats, we can collectively work towards a safer and more resilient digital future.